Thank you so much for inviting me, Mikhail. Yeah, so it didn't take much to persuade me, really. It's very lovely to be here and to meet this crowd of developers from Malmö. So I decided I would like to talk about test-driven development. And about the time Mikhail mailed me, there was this controversy going on in the blogosphere with TDD is dead and all this. So I thought, okay, I can speak about that. That will give me an excuse to read all the blog posts and all the stuff and find out what this thing is about. But anyway, before I start, I should just say I've got some company names on here. I have 3 jobs at the moment. It's complicated, but I should just mention Metrical, consultancy company specializing in continuous delivery and automated acceptance testing that I'm doing some work for. So if you need any of that stuff, talk to me afterwards. Anyway, so I'm actually here to talk about, is TDD dead? Well, of course it's not dead, but there is a great bit of fuss going on around it, which I would like to talk about. This guy, David Heinemeier Hansson, wrote a blog post called Test-Driven Development is Dead. Long live testing. And in this blog post, he attacks test-driven development and criticizes it and says all these things. And one of the lines in the blog post is, "My name is David, and I do not write software test first. I refuse to apologize for that anymore, much more less hide it." So this is kind of the general feeling of this blog, is that he's coming out of the closet and saying, I don't do TDD. But that's okay. So this is kind of surprising coming from David Heinemeier Hansson. He's the creator of Ruby on Rails. And the Ruby community generally is well known for being well up on TDD and testing. They have all these great tools like RSpec and Cucumber and Water and Capybara. And I was just saying they've got the best testing tools. And I think that was, somebody was challenging me on that. That's probably true 5 years ago. They definitely had the best tools a while back, but everything else is catching up. But anyway, they were really early adopters in the Ruby community of test-driven development, which makes it all the more shocking that this guy comes out and says, I'm not doing it, and I'm not apologizing. So what is going on here? Well, after this initial blog post, he did a keynote, and then he started talking to Kent Beck and Martin Fowler, and they decided to make public some of their conversations in the form of these hangouts that they put online. And they had 3 or 4 very thoughtful conversations where David was putting forward his criticisms and Kent and Martin were responding to this. And I watched these and I felt, okay, they had some good arguments and some good discussions, but it made me really have to think about how I would answer these criticisms, because I wasn't always satisfied with the answers that Beck and Fowler came up with, actually. So I was challenged to think for myself. So that's kind of what I was going to share with you tonight, really, was what I thought of these criticisms. So the main criticisms that I picked up from the blog post that he said were, test first is like some kind of fundamentalist religion. It's all about guilt and forcing people to do testing, and it's terrible. Okay, and the next point he comes up with is, well, test first is bad for your design. It leads to design damage. That's pretty shocking, since TDD is supposed to be good for design. And then the last criticism I think he really comes up with is that there's just too much focus on unit tests. We should put our focus elsewhere. Don't do this unit testing thing. Let's do these other kinds of testing. So I was going to structure this talk basically to go through these 3 criticisms, and with a bit of a tangent at one point. We'll come to that. So before I go into these criticisms, I wanted to just make sure we're all on the same page. What is test-driven development? What is this thing that we're criticizing? Well, it is, for me, it's a profoundly different way to approach a coding problem. It's putting the creation of automated tests right at the center of your development process, forcing you to work incrementally. It becomes absolutely central to the way you work. So I would characterize this kind of test-driven development in the very narrowest sense as being like this. So you must write a test for every line of production code that you're going to write before you write the production code. So every line of code is being driven by a test. The whole development process, it comes test first. And when you're testing a piece of code, you have to completely isolate that piece of code from all the surrounding code using test doubles, mocks, stubs, that kind of thing, so that you really know that you're testing this thing, and if this thing breaks, then my test will tell me. And this test won't break if that thing over there changes. It forces you to do your design in tiny increments. I've put this by the refactoring step in TDD, because you do have to do design in refactoring. You have to know what you're refactoring to. But of course, you also design every time you design a test case. So you find yourself doing design all the time in small steps. And you get very often to a state where all the tests pass and the thing kind of works, and then you go for the next increment. So you're going around this cycle every few minutes, ideally. And then what you end up with then is hundreds of tests that will run in less than a second. So they're really, really fast because they're testing these really isolated units. They're all running in memory, and they're like this to run them. And when one of them fails, you can see, that test has failed. That means that unit isn't working. So they're pinpointing your regression problems. So this is a very narrow definition of test-driven development. And this is, I think, the kind of TDD that David Heinemeier Hansson is criticizing in his blog post. Now, all this is very specific, but I wanted to emphasize as well that if you're doing this kind of development, you get this wonderful, productive freedom. You feel that the code and the tests are just flowing, and the functionality is growing before your eyes, and you are totally free to refactor and improve your code and go in any direction with it. So when you get into this TDD and it's working, it's brilliant. So it's all the more kind of shocking to hear David Heinemeier Hansson. So I know he can do this kind of TDD. He says himself in the blog post, I've experienced TDD, I know how to do it. And yet he says he doesn't want to. He doesn't find it useful. But it's so cool. What's going on here? So that's the kind of TDD that he's criticizing. Let's look at the first criticism. It's like a fundamentalist religion. Well, I don't actually know quite what he's referring to, but I suspect one of the things he may be referring to is, this is Robert C. Martin, and Bob is a fantastic speaker, but he has this huge persona when he goes up on stage, and he does this thing where he points the finger. Are you a professional? Do you write tests first? This whole idea that if you don't, then there's something wrong with you. And he does it kind of because he has this great stage persona. He's a fantastic speaker. He tells wonderful stories. But I think that perhaps he goes over the top, maybe. This fundamentalism, you must write tests thing. I don't know. I pick on Bob because I like him, but he's not the only one that has this kind of fervour when they're talking about TDD, because it's so good when it's working. And I think the thing with this is David is pointing out, I guess, that this advice is not directed at him. This sign here says experts only. And I think that's a bit where David is. He's the expert. Bob and these other speakers, with their fundamentalist fervour, are trying to persuade people who've never written a test in their entire life that it would be a good thing to try. And they're just maybe being a little bit over the top about it. So actually, David is not the target audience for this kind of thing. And Seb Rose, that's his blog post where he points this out, and I think he explains it quite well. But this gives me an opportunity to then go off on a tangent and talk about beginners, people who haven't experienced TDD, people who don't know what this is, and talk a little bit about how you would go about learning TDD, or if you're already, one of the saved who actually likes TDD, how you can persuade other people without putting them on a guilt trip, because I think that's probably what we're trying to avoid here. So I've actually written a book called the Coding Dojo Handbook, which is all about learning test-driven development, actually. So one of the things that I do when I'm working with programmers who want to learn TDD is we do code katas. Now, how many of you know what a code kata is? Oh, pretty much everyone. Excellent. Yes. So this is you're clearly not beginners here. This is good. But in karate, a kata is this sequence of moves that you do and you repeat until you can do it perfectly. And a code kata is similar. It's a small coding problem that you'll do more than once so that you get better at it. And you learn a technique through the code kata. And Dave Thomas came up with the idea. So I've got an example code kata here. This is a very simple one. So you have to write a function and it returns true or false depending on whether the input integer is a leap year or not. And then it gives you the rule, which is kind of complicated. And then it gives you some examples. Now this is a very straightforward function to write. It's just a few lines of code, depending on what language you do it in. It might only be one. I'm sure that everyone could write this function with no tests whatsoever and probably get it right. But the point with this code kata is to practice doing it with test-driven development. So you learn the moves of TDD. How does it feel when I'm doing TDD? And these 4 examples turn into test cases fairly easily, and you build up incrementally a function that returns a Boolean. Now, once you can do that, the world's your oyster. Well, not quite. There's probably other code katas that you might want to practice on too, so that you could test drive something a bit more complex than a function that returns a Boolean. But the point is that you can use these to help you to learn skills. The thing about code katas, just doing them by yourself at home, gets a bit, boring. So there was a couple of French guys who proposed that we extend the analogy with karate and have a coding dojo. Just like with karate, you go to the dojo and learn with others. You could do the same with coding. So this is the premise of the Coding Dojo. It's much more fun to do code katas in a group. So you can come up with some kind of regular meeting. And here at Food Cafe, I think you've had coding dojos here, actually. I forgot to ask Mikael before. But you could do it with a group of people you've just met at Food Cafe, or you could do it with your team now and again, maybe every iteration or something. And you can meet together, do some code katas, and write some tests, and discuss and collaborate and work out how to do TDD. And there's some more to it, but I've written a book about that. And a Pluralsight video, in case you prefer a video. Now, I wanted to bring up Dan North's talk, because he was here 2 years ago for the opening, and he said that you need to optimize for learning. And he gave I've watched the video, I wasn't here, but he gave this really inspiring talk about Food Cafe and how it was great to be able to meet with like-minded people and learn stuff together, which is the whole premise of this. That's great. But one of the things he said bothered me, because he criticized code katas. And he said that a code kata is not worth practicing. You're optimizing the wrong thing, because you're optimizing for performance. And when you're practicing your karate moves, it's so that you can perform this kata together with your other people in your dojo and show off how good you are. And it's the same with a code kata, that you'd practice it so that you can perform it. And this is nothing like real coding, because real coding, you never do the same bit of code twice. Well, mostly. Mostly you're writing something new because the customer wouldn't pay you to write something that already existed, I guess, most of the time. So Dan North was like a bit down on code katas. So I felt that I had to counter this with some kind of arguments that actually, no, I think this is useful. I do think that code katas are a useful thing to do. And you're not just learning to perform something. Because even if you look at karate, they're not practicing the kata really to perform it. They're practicing so that they can spar. And that's sparring, fighting. Is much more fluid and spontaneous, and they have to know the moves of the kata so well that they can bring them out without thinking. It's similar with musicians practicing scales. They don't practice scales to perform scales. They, like jazz musicians, will practice a lot of scales, and they'll all come out when they're improvising in some new and innovative way. And I think it's the same in code katas. You're practicing the moves of test-driven development, not so that you can perform that kata, but so that you can bring out those moves without thinking about it in real code. So next time you're writing a function that takes an integer and returns a Boolean, you think, oh yeah, I know how to test drive that. I did a kata on that last week. And that's kind of the motivation. So it's not just learning a script, it's learning some moves. And the code katas have lots of other benefits as well. So this is a tool that I use in coding dojos from time to time called CyberDojo. And one of the things it does is it records every time you run the tests, whether they passed or not. And time increases on the x-axis, so you can see how long a gap you're leaving between your test runs. So these are two example test run logs from a pair from complete beginners at TDD, at their first coding dojo, and then how a similar pair was doing after 6 dojos. Not 6 dojos working on exactly the same kata, I have to say, little different exercises and stuff. But I think you can clearly see that there's a difference. The tests are being run more often, there's more green, and if you look carefully, you can kind of see cycles appearing, where you have the failing tests, you make them pass, then you do some refactoring, then you write another failing test, and you make it pass. You don't see long strings of failing tests, for example. So this is a tool that we use when you're practicing TDD with a code kata. You can monitor afterwards, you can review, how did that go? Was I doing incremental development? Did I mess up at some point? Should I have stopped and when all these tests failed all the time and reverted the code? You can start to have a discussion after you've done your code kata with your pair programming partner and work out how you've done. So this is things that you can do with code katas. You wouldn't probably do this in your production code so often, but a code kata is a little thing you can stop and talk about it. So practice. This is what we're doing with these code katas. We're practicing. And I wanted to just clarify a little more about what practice I mean, because there are two kinds. There's incidental practice, and this is where you repeatedly do something you can basically already do, and that's probably the kind of practice you think of when you think of practicing something. But there's this other term called deliberate practice, and this is where you're actually trying to do something that you can't comfortably do. At the moment, while you're doing this, you have to actually force yourself because it feels awkward to do it like this. And that's how it feels when you're just pushing yourself beyond what you can currently do. Just the right amount so that you can quickly get back to incidental practice and start just incrementally improving at it. But one of the things you'll do as part of deliberate practice is to break a skill down. I'm a musician, so one of the things I do when I'm trying to play a piece of music that's too hard for me is I'll take the hardest bit and just practice that bit by itself, and slowly. And then eventually I'll put it back and play it with the whole piece. It's that kind of thing. It's identifying the hardest bit, pulling it out, practicing it, and then putting it back into the whole. So that's something you can do with test-driven development. You can pluck out one aspect of it, like how to do refactoring, and just focus on that. Or how to write good test cases. or there's a number of component skills in TDD that you can pluck out like that. But the point with deliberate practice, I guess, is that I wanted to make is that if you're going to do deliberate practice, you have to feel safe. You have to be okay, willing to be uncomfortable, willing to try something you know you can't really do. And just take that step out onto that high wire, know that there's a safety net. It's okay. And that's one of the things that happens in the coding dojo. You're working on a code kata. No one cares if you break it or if it doesn't work, or there's no deadlines. There's a safe environment to try out a new skill. You also need motivation to want to learn the thing, to want to step out onto that scary looking high wire. You need to feel that there's a reason for you to do it. And that's another thing the Coding Dojo helps with, or Foo Cafe. There's people around you who are encouraging, who will have gone and done this before, and they can help you. And you know that they'll help you with the motivation to want to learn it. So that's a good thing about learning TDD. Find a dojo, do some code katas. And then this incidental practice thing. This is where you're training your habits. And I like this quote from Kent Beck, where he says, "I'm not a great programmer. I'm just a good programmer with great habits." And he is clearly a great programmer. He invented test-driven development, basically. But he's saying that the important thing that he sees about his skills is that he has good habits. It's natural for him to write tests because that's what he does. He's trained himself. He's practiced that for so long. So in the dojo, you also get into the habit of writing tests on code katas. But I think I really wanted to say about test-driven development is this feeling you get when it's working is fantastic. This feeling you get when those tests run like this and they are all green and you know you can do anything with the code because those tests will tell you if you go wrong. And just that's what you can experience fairly easily on a code kata, because code katas are problems that are very well suited to test-driven development. They're kind of set up like that. So it's much easier to be successful with TDD on a code kata than it is with your production code, probably. Your production code is probably quite difficult to do TDD in, at least at first, until you get the hang of it. So just going back to this thing with, are you a professional? Can I make you feel guilty? No. I think that the attitude has got to be, test-driven development is great. You've got to try it. This is fun. Look, come to my dojo. Try a kata. This is what's going to get people doing TDD. So I'm not into this fundamentalist religion and this guilt trip. I think that's Bob being a little bit over-enthusiastic. And we can forgive him because he's such a good speaker. And nice guy and all that. Really. So anyway, I think I've dealt with David's first criticism of TDD. So I'm back off my tangent. I was on a tangent there with coding dojos, but now we're back on David's criticisms of TDD. And I think we're on one of the most serious allegation, I think, of the three, that TDD is actually bad for your design, leads to design damage. That's completely the opposite of what I've always thought. So let me explain why I think TDD is good for your design, so that we have something to go from. So if you're doing TDD, when you write the test first, before the implementation, it forces you to design the API to whatever it is you're going to call. Because before the thing exists, you have to decide how you're going to call it. What's the method going to be called? What are the arguments? And that's design. That's designing an API. And the cheapest time to change the API is before the implementation exists, surely. So this is good. You also have to decide what collaborators you're going to need, what arguments to send to the method, what classes you're going to have to construct in order to construct the thing you're trying to test, which ones you need test doubles to replace. So this is, again, you're doing all this before you have the implementation. It forces you to think about your design. So this has got to be good, right? I also have some evidence here, this guy, Luca Minudel, he wrote a paper a little while ago and about how people who were good with test-driven development wrote code that was more likely to follow object-oriented design principles, like dependency inversion principle, single responsibility principle. And I've got a picture of a racing car there, because he actually worked for a Formula One racing team. So it's pretty cool. And he's got like evidence here. TDD is good for your design. So one of the aspects of his study was to do some little exercises with people. So I turned one of these exercises into a code carter. In fact, I turned several of them into exercises, into code carters. Has anyone done the tire pressure code carter? One person, yes. So nobody's seen this before. Okay, so this is a spoiler alert here. I'm going to tell you how to solve this carter, or the point of it. But it's okay, because there are others as well. If you look on GitHub, I've got several of these things. So even if you know how this one works, you can still do the others. So the point here is that we have an alarm class, which knows whether it's on or off and has some logic to decide whether it's on or off. And we have a tire sensor, which is attached to some kind of racing car and will tell you the tire pressure on the racing car as it's racing. And there's some complicated stuff going on there with pounds per square inch and stuff. But the point is that we have got this code and we want to write a unit test for the alarm class. Now the trouble is the alarm class has this direct dependency on this concrete class, the tire sensor. And the tire sensor is pretty awkward to instantiate in your unit tests because it needs a whole, a tire and a car and, stuff like that. This is not the kind of thing you just create one of in your unit tests. So it makes the alarm class pretty hard to test. So what you have to do to get the thing tested is you have to introduce some kind of interface, a sensor interface, and so that you can replace in your test with a test double, so that the real implementation can continue using the actual tire sensor, and in your test you can throw in something else that implements the sensor interface, some kind of test double, and then you can test the alarm class and it all works. So what you've done is now the alarm class actually depends on an abstraction, an interface, rather than a concrete class, and that makes it testable. Now, if you notice, what we've just done is made the alarm class obey the dependency inversion principle. Because the dependency inversion principle says that you should depend on an abstraction, not a concrete implementation. So testability and the dependency inversion principle, they're like this. It's very clear, for me at least, that there's a very direct relationship between code that is testable and code that obeys the dependency inversion principle. And for some other object-oriented design principles, like the single responsibility principle, there are similar correlations, I think. So I think it's clear to me that TDD ought to lead to better design principles in your code. So let's look at what David has to say. He claims that TDD causes design damage, and he helpfully provides an actual concrete piece of code as an example of this kind of design damage. So he has the code before and the code after the design damage. And the code before is like 10 lines of code, and afterwards it's like 40 lines of difficult code. So this is the before step. This is the code. It's Ruby on Rails. This is a controller class. Does anyone know Ruby or Rails? Oh, a few people. Good. So this code I'm not going to really go through, but basically I wanted to point out that this is a class involved in saving stuff to the database and telling it what to show on the screen afterwards. So this is really designed. The controller class is integrating what's going on with the user interface with what's saved in the database. It's kind of connecting them together. So this is, you want to unit test this, you've got to isolate it, which means you have to isolate it from the user interface and the database. So he shows an example of how you could do this. And what you end up, this way of doing it, I didn't write all the code out because it's like this long, but suddenly you've got 4 classes instead of 1. The original was the employee's control, and now you've got 4 classes, and you've got all these layers of indirection between this controller and the database, and between this and the GUI. And it's hugely more complicated. And what David says about it is that you are harming the clarity of the code through needless indirection and conceptual overhead, which is it's quite specific. He's saying needless indirection, and I think he's got a point. This thing is way overcomplicated for what it's trying to do. And if you think about this idea of indirection, there's a famous quote by a guy called David Wheeler, who's a very famous computer scientist. He said, "All problems in computer science can be solved by another level of indirection." And then Kevlin Henney says in Riposte, "Well, except the problem of having too many layers of indirection," which is a good observation, I think, for this particular case, because you've introduced several layers of indirection and you've made the code obfuscated. You don't understand what's going on anymore. But let's have a look at this here, where we made the alarm class testable by introducing a layer of indirection, effectively. We've put this interface between the alarm and the tire sensor. We've introduced indirection to make it testable. So he has a point. TDD does push you to add layers of indirection, actually. And it's partly this thing with TDD that you want to isolate all your units completely in order to test them. That causes you to add this indirection. So this class with all these touching the database and the GUI, it's tricky to isolate. But actually, some blogger pointed out that actually it's not. He's got an example here of how you can test this without introducing all these random layers of indirection. So actually, you don't need 4 layers of indirection or whatever it was to test this thing. So why would anyone do that? Why would you have these? Well, actually, if you read the original motivation for it, it's so that you can scale. It's not so you can test it, it's so that you can scale to having a very big application with lots of classes and methods, and you have to find a way to divide up these responsibilities when you get to a big application. So actually, the example that David gives is a little bit disingenuous, because it goes overboard on indirection, but you don't need that much to test the thing. Anyway, so my point basically is that test-driven development does affect your design. He's right in that. But the way it is that it pushes you away from this having very tightly coupled classes towards using the dependency inversion principle. It pushes you towards layers of indirection. But it won't suddenly turn you into some kind of expert designer who knows when that's appropriate. So I think there is a grain of truth in what David is saying, that you can take it too far, you can overdo it, you can do over-design, you can add too much indirection, and TDD might encourage you to do that. But hey, design is hard, whether you're doing TDD or not. So that's the second criticism. Then I wanted to talk about the third criticism, that there is too much focus on unit tests and we should be looking at other kinds of tests. Now, I don't really know, this didn't come up in the Hangouts, but I think what he's talking about here is this focus that is often had on the agile testing pyramid. Let me just explain this. This is the idea that Mike Cohn came up with, that you should have a few tests through the UI that are full stack, just a few, quite a few service tests that check whole functions through some kind of API, and a lot of unit tests which test things in isolation. Who's actually seen this before? Oh, quite a lot. Good. Not everybody. Because this is typically wheeled out to say, concentrate on unit tests. That's what you need most of. And I've even seen people put numbers on this. So this was a guy from ThoughtWorks. I asked him afterwards, where did you get these numbers from? because he was very sure that you should have 70% of your tests should be unit tests. I'm like, and he said, oh, this is what we found from experience in our work at ThoughtWorks, that this is the kind of ratios that are best. I said, okay, best? Best practice? I thought we got rid of best practice in Agile. Anyway, again, I wanted to just point out, well, who is this advice about the testing pyramid actually aimed at? Well, I don't think it's aimed at the experts, clearly. This kind of really rules about you must have more unit tests than every other kind of test, that's a beginner rule for people who don't know what they're doing. That's not the kind of advice you give to an expert like David Heinemeier Hansson. And he's, I think, just reacting to that he needs a different kind of advice. But let me just talk back about TDD, because one of the things that you get when you do TDD is this test suite that runs really quickly and finds your regression errors. It pinpoints defects that you introduce. And that's a really good effect of TDD. And it's, along with the TDD affects your design, it also gives you this possibility of refactoring because you have regression tests. But actually what you want is self-testing code, which is a somewhat more general concept than just I have some unit tests or I'm doing TDD. And Martin Fowler talks about this in the Hangouts. And he's written a blog post with a definition where he says you can have self-testing code when you can run a series of automated tests against the code base and be confident that if the tests pass, your code is free of any substantial defects. So this is a definition of self-testing code by Martin Fowler, which I like very much. And it doesn't say anything about what sort of automated tests they are, whether they're unit tests or whatever. And this is deliberate because you can have self-tested code even if the test suite takes hours to run. It's still useful and it can still help you. And if you go back to this pyramid, of course, all of the kinds of tests in this pyramid are necessary to achieve self-tested code, I believe. I don't think you can have it without all of the kinds. Well, possibly you can miss out the service tests, but then that would be problematic. But so if we look at the different kinds of tests, they have different trade-offs, they have different benefits. If we look at the unit tests in an application, they will run in seconds. True unit tests will be really fast, so you get very fast feedback. And they will pinpoint defects directly at which unit has got a problem. And generally, the maintenance costs of unit tests are fairly low. It's usually when you're refactoring, updating the unit tests shouldn't be a huge burden. Now, if we look at the other kinds of tests here, the API tests and the full stack tests, they are testing whole features. So that means that they're immediately very valuable because if a whole feature is not working, your customer is going to care. This is going to highlight important problems with your system, hopefully. It will also find integration errors. Now, unit tests by definition will not find integration errors because they test units in isolation. And integration errors can be a very significant kind of error that you actually get in your application. So you would be unwise to not have any of these tests for your application. But the problem with them usually is they're much harder to maintain. It's much more difficult to write one of these tests in such a way that it's cheap to update when the system changes and that doesn't just get thrown away shortly afterwards. I've seen this happen many times. You get a lot of enthusiasm, you build this whole system test suite, and then some key person leaves or some deadline comes along, the tests get out of sync with the application, usually the GUI changes and the tests don't hang a med, and then suddenly you throw away the test suite. It's not giving you anything. So these are harder to do, but I think they're absolutely necessary. So now I'm going off on another tangent because I'm really quite keen on these kind of these tests that are whole feature tests, system tests. I think they're really important. And I've been using a technique for a number of years now, which I've come to call approval testing. And it's particularly suited for this kind of whole feature tests and for legacy code, incidentally. So it's a technique I wanted to talk about so you know what it is. A lot of people know what it is, kind of, but now it has a name and you can talk about it. Approval testing. So imagine you have a command line program. This is a very simple program to test in this way. That's why I'm telling you about it. Not that you should all go and write command line programs. But if you had one, it's going to take on standard input, a little text file containing information about where the mines are on a minefield. Do any of you remember a little game? Came with a certain operating system. You had to cross where the mines were. Yeah. So this isn't that game. This is a really, really simple little program. It's a code carter. But it has to produce a standard output. The clues, how many mines are next to this space. And it outputs it to standard outputs as a little, ASCII art. And this code carter is quite fun to code up. But then how do you, of course, test your code? Well, if you're in a kind of a unit testing mindset, you'll start thinking about, well, I need to make some assertions. I need to put a mine there and then assert that the space next to it gets a 1. And then when I put 2 mines, then I get a 2. And that kind of thing. Approval testing is saying, okay, let's not do asserts like that. Let's do asserts differently. Approval testing says, well, when I design a test case, I just design the input data, then I build my code, and I run the input data through my code, and I look at what I get, and if I like it, I approve it. And then I've got an assertion. I've just approved that is the output I expect. Now all I have to do to run my test is to diff the new output that I get when I run the thing again against my approved version of the output. So suddenly you've got an assertion that checks the entire output by default. So what happens when this test fails? Well, of course you get this diff, and you're all programmers, you know what a diff tool looks like. And because these are text files, they're dead easy to diff. And you can see clearly, I've made a mistake here maybe. I've got some zeros that I shouldn't have had. The question is this a bug or a feature? Now you always get this when a test fails. Is this a bug or a feature? Well, let's just say this is a bug. I don't actually know. Maybe this is some optimization I made that came out wrong, and when there's no mines in the area, I put zeros in by mistake. I have a test that fails that tells me this, and I have a test with realistic input that's checking a minefield which has some kind of boundary condition, and I can see that it's failed. If I'd been writing unit tests for this, I might have been a bit lazy and only written a test for a minefield with, 3 by 3, because that's the kind of thing you do in a unit test, and I would never have discovered this bug. Or I might just have forgotten to write any assertions for what's happening at the edge. Whereas this approach, by default, it checks everything. And the way you normally do it is you try and give it realistic user-derived input. So hopefully you're going to find useful bugs, interesting bugs with this approach. The other thing about this is it could have been a feature. Maybe I wanted there to be zeros at the edge of the minefield. And actually, I want you to imagine that I actually had more than one test, and they've all failed in the same way. They've all suddenly got zeros around the edges of the minefields. And I've got 5 tests that failed. And I want to update them all and approve this is what I wanted, actually. So I need a way to turn this new output into the approved output. And that's got to be quite easy, or else I'll quickly get fed up of copying and pasting strings into source code, which is what you'd be doing with a unit testing tool. So this has got to be a kind of tool support for approval testing. I think you need that. But then once you have it, it becomes a very easy operation, a push of a button to say, I approve the new output. This is what I want to see now. So you start managing the behavior of your application and seeing it as a journey, that you expect the behavior to change, and you have an easy way to update the tests when it does change, rather than asserting some kind of universal truth that you don't ever expect to change. So I think this is a very agile way of testing. And when I talked about tool support, I have to, of course, mention TextTest, which is a tool I'm one of the contributors to. It has a website, TextTest. So if I'm going to summarize approval testing for you, it's all about using diffs against this kind of approved output that you've previously checked. And you can easily update the approved version. And I think this is particularly suited to these more whole feature or system tests that you should have in addition to your unit tests, probably. So when I look at this testing pyramid and the advice about you should have 70% unit tests and only 30% of these other kind of tests, I'm like, that is a rule of thumb for beginners. Once you know what you're doing, you have to tailor the pyramid to your circumstances. As David puts it, if you have a very simple model layer but your UI is complex, then you should have lots of system tests and maybe not too many unit tests of your model. It's got to depend on your situation, what kind of tests you need to regression test your application automatically. So I think David is pointing out again that the advice for experts needs to be more nuanced, and we're not hearing a lot of that. We're hearing a lot of advice for beginners. So this is my final slide, where I'm going to present my conclusions, basically. So is test-driven development dead? Well, of course it's not dead. It's still a very useful technique in many situations that I use myself. David Heinemeier Hansson has introduced some criticisms that this fundamentalism, this design damage, this don't focus on unit tests kind of criticisms. And he has discussed this with these eminent gentlemen. And I think they didn't say everything that needed to be said, so I've got some of my own ideas. The fundamentalism, what I said was about code carters. Try and encourage people to try TDD on a code carter so that they will experience how good it is and want to learn it. Don't try and beat them over the head and call them unprofessional. I think that's good. This thing with design damage, I think you need to be aware that when you're doing test-driven development, it does push you in the direction of adding more layers of indirection. It will push you towards the dependency inversion principle in particular. And you need to be aware that you can go too far with that. And you can end up with some kind of mess of Kevlin Henny. Too many layers of indirection. I can't see what the code does. Where's it doing something? That kind of problem can arise. But if you have a responsibility as a designer to do a good design. But it's good to be aware of your biases. And then on this last point about not only unit tests, I think I'm with David on this, that there maybe is too much talk about unit testing. And it would be good to hear a bit more discussion about how to do those other kind of tests well. Because there's a lot of people writing very bad tests in those areas, and even there's a lot of people writing bad unit tests as well, to be honest. But I think it's time we talk more about that. How do you write good tests? And approval testing is an approach I believe in, particularly for this kind of test. And then just as the overall message from what I'm saying is that a lot of the advice you hear about TDD is aimed at beginners. And if you're not a beginner, you need to know when you should stop listening and realize that you've transcended those rules and that you should do something else, like David himself is clearly doing. So, thank you.